Earlier on in the course, I mentioned that C# was a strongly typed language, meaning that you can't just simply declare variables and not tell the system what the types are. You'll find that as you build your C# programs, this actually becomes quite an advantage rather than the encumbrance that it sounds like. Programs store and keep track of all kinds of data. They keep track of numbers and prices and names and email addresses and dates. And these pieces of data are stored in memory locations called variables. And each piece of data can have a type which is used to declare a variable. In some languages, such as JavaScript, you can declare variables and you can change their types around. You can do all kinds of great stuff. And you can't do that with C#. So for example, in JavaScript, you could just do this. You could say my data is equal to true. That's okay in JavaScript. You can't do that in C#. You have to actually declare the variable. In JavaScript, if you just use a variable without declaring it, JavaScript assumes it's a global variable. Well, C# doesn't have global variables, so this wouldn't work. You have to actually declare it. So you declare it. In JavaScript, you can do things like var my data equals 1, 2, 3, 4, 5, 6. And in fact, you can do this in C# too. C# does support the var keyword, but it's a little bit advanced for C# and we're not going to cover it in this course. However, in JavaScript, you can do things like this. Once you've declared the variable and you've assigned it a number, later on in life, you can say, hey, you know what? My data is a text string now. Again, that's okay in JavaScript, but you can't do that in C#. Your variable can't change type once you've declared it and once you've initialized it. So that's an example of things that work in some other languages that don't work in C#. So how do you declare and name a variable in C#? Well, let's take a look at that. To declare a variable, you simply indicate a type, and then you give it a name, and optionally, you can give the variable an initial value. So all of these are valid ways of declaring and, in some cases, initializing C# variables. C# variable names can start with a letter or an underscore. And after that, you can have letters, numbers, underscores, up to 255 characters. Now, you can't start a variable name with a number. It has to be a letter or an underscore, and the letter can be upper or lowercase. Remember that C# is case sensitive, so uppercase and lowercase variable names are different. So you have to keep that in mind. This will sometimes lead to bugs for newer C# developers who've come from languages where things are not case sensitive, they're case insensitive. That's not the case here with C#. You do have to remember that. C# has a number of primitive data types that are built into the language. And the reason they're called primitive data types is because they are the basic building blocks that you use to build other data types. For example, and you've probably seen me using some of these throughout the course so far as we've built some of our examples. There's the int data type, which is an integer. That's 4 bytes. And it holds numbers from about negative 2.1 billion up through about positive 2.1 billion. There are date data types. The date is 8 bytes, and it represents January 1st from the year 1 up through midnight on December 31st of the year 9999, which is a very long time. There's also a char data type, which is a single character, and that's 2 bytes because it's Unicode. Unlike other languages where a character is 1 byte, in C# it's 2 bytes. There are strings. Strings can hold from about 0 to 2 billion characters. That's a very, very long string. There's also an object type. And in this case, the object is actually defined by your program, although C# and .NET does provide a base object definition for you. And it takes up as much memory as its structure and as memory allows. So you can have all kinds of data fields inside your objects. And then rounding out the primitive data types are a whole bunch of other types like booleans and bytes and decimals and doubles and all kinds of other numeric data types and boolean and other non-numeric data types. There's also a special kind of data type in C# called a nullable type. A nullable type can represent the full range of values of the normal underlying data type along with the additional value of null. Normally, when you declare a variable like an integer, it has to be a number. You can't set that variable to null like you can in JavaScript. In C#, if you want to be able to do that, you have to declare what's called a nullable type. This is a little bit advanced, and we won't see very much of it in the course, but I wanted to point it out to you because you will occasionally run across it in your C# travels, so I want to make sure that you know what it is. So a nullable type, like I said, it can be null, along with whatever its normal data type is. So for example, if we declared a Boolean variable with the name of b, that can be either true or false. If you try to do this, however, set it to null, that's an error. You can't set b to null. If you want to do that, you have to declare the Boolean variable as a nullable type. And the way you do that is you declare it as a bool with a question mark at the end. And that tells the compiler, hey, this is a variable that can be either true or false or null. You can do the same thing with integers. If I put a question mark on the end of the integer, it can be an integer value or it can be null. Using these kinds of primitive data types, you can build all kinds of C# variables and higher order objects, which we'll see a little bit later in the course. For now, though, now that we've seen primitive data types, there's one other thing we need to look at and understand, and that is how C# deals with the notion of objects.